Okay, here we are, Stats and Mechanics Year 1, Chapter 10, Question 9. In this question, I and J represent the unit vectors east and north respectively. The forces are 3ai plus 4bj, really, 5bi plus 2aj. Okay, and minus 15i minus 18j. Okay, act on a particle of mass 2 kilos which is in equilibrium. Find the values of A and B. Okay, so all of these are acting together, so they should all add up to 0. Okay, so let's just do this in column format. 3a and 4b added to 5b, 2a, added to minus 15i, well, don't need the I on that, do we? And minus 18 in the j direction is equal to 0, 0. Okay, it's in equilibrium, it is not moving. So what do we have there? We've got 3a plus 5b equals 15, just moving the 15 to the other side, and we've got 4b plus 2a is equal to 18. Okay, pair of simultaneous equations to solve. Okay, so a equals b equals, you don't need to solve these, you can just do it on a calculator. Okay, so straight onto the calculator, putting in the information, simultaneous equations, there it is, number of unknowns 2. Make sure, just watching out the way that's come around, A's are in different places there, so make sure you put the correct things in the correct places. Okay, 3x5 y is equal to 15. Okay, I know my calculator wants the number on the other side of the equals, which is why I set it up like that. And then I need 2a and 4y is equal to 18. And we end up with the a being minus 15 and the y or the b being 12. Okay, there's that. Okay, so now if the force minus 15i minus 18j is removed, work out the magnitude and direction of the resulting acceleration of the particle. Okay, so they're taking out this force, so we can have the forces be, so let's have the 3 times minus 15, 3 times minus 15, and 4 times 12, plus, get that into column vector format there, 5 times 12, and 2 times minus 15, 2 times minus 15, too many brackets, is equal to the mass, which we were told was 2 kilos, don't know why I've written 2 kilos, times the acceleration. Okay, was that right? Just find the acceleration, magnitude, and direction of it. Okay, so let's go see what we end up with here. So, taking those, so what do we have there? Minus 45 plus 5 and 12, 5, 12, 60. Okay, and 48 and minus 30, okay, is equal to 2a. So 60 minus 45 is 15. Okay, so we end up with 15 15 over, what's that one? 18, 48, yeah. Equals 2a, and so half of both of them, 7.5, 18 over 9 is equal to a, dividing by the 2 there. So we now know the force that is acting onto it, but they want to know the magnitude and the direction of the resulting acceleration. That's not a magnitude. That is 17 or 7.5 in the east direction and 9 in the north direction. Okay, and so we want to know what that is, and then we also want to know what the angle is as well. Okay, so quick bit of Pythagoras on that. Okay, square root of 9 squared plus 7.5 squared, okay, will equal a. So square root of 9 squared plus 7.5 squared gives us 11.71. 71 meters a second minus 2. Okay, and now what we need to do is we need to have a direction on it. So it would make sense that if we start from the north line for a direction, to give ourselves a bearing. Okay, so what do we have there? Still the 7.5, still the tan, adjacent, opposite, don't we? So tan. So the tan of that angle is equal to opposite, which is the 7.5, divided by the 9. Okay, and so that angle is, just check your calculators in degrees as always, the inverse tan of 7.5 over 9, which gives us about 39.8. Okay, 8. So I would give the direction maybe as a bearing. A bearing, which means it's coming from north already. Okay, a bearing of, let's just call it 40 degrees. All right, the distance traveled by the particle in the first 3 seconds of its motion. Okay, so there's your answers there, that one and that one. Right then, distance traveled, so we need to consider suvat on it. So distance is what we're looking for. Did it start at rest? It did, I think. It was at equilibrium, it then got moved, the force got removed, so we started at rest. Final speed, I don't know. Our acceleration is 11.71 and time is 3 seconds. So we are looking for something without v in it as an equation. So we can use S equals ut plus a half at squared, and so we can have 0 times 3 plus a half times 11.71 times 3 squared. And so the distance traveled in the first 3 seconds is 11.71. 11.71 multiplied by 0.5 multiplied by 9 gives us 52.695. 52.69570 meters. Okay, that's all.